Good morning, dear students. Last class, I have given concept and definitions of relation. At the same time, how we are taking a relation from the given two sets also I have told. And I told every subset is a relation. About this also we discussed in the previous class. And after completion of that, I have given types of relations, that is null relation or void relation or empty relation. And I told about all these things. These three are giving same meaning. And afterwards, I have given concept and definition of universal relation also. And after completion of those, I have given concept and definitions of domain, comma, range, and codomain of given relation. To all these three, I have given set builder form also. I have given an important formula to all these three: domain, comma, range, and codomain. And today also we'll discuss about one more important relation, that is the inverse relation. And after completion of this, next we are going to solving the problems from exercise 2.2. Now let us, I am going to giving definition for inverse relation. Inverse relation. Inverse relation. Inverse relation. Let capital A and capital B. Let capital A and capital B. Let capital A and capital B be two sets. Be two sets such that if the relation defined from A to B, then the relation defined from B to A is called inverse relation. Is called inverse relation. Is called inverse relation. Inverse relation of R, and it is denoted by R inverse, just representing with R power -1. First, you define relation from A to B. Then afterwards, if we can define that from reversely, if we can move reversely B to A, then that relation is called inverse relation. A to B first you define. You consider A and B be two sets such that if the relation defined from A to B, then the relation defined from B to A is called inverse relation of the given relation capital R. At the same time, it is represented by R inverse. See here, for example, ordered pair A comma B is there. A comma B is there. Just if you can move reversely means, then ordered pair becomes B comma A. Like that, you can you can take inverse to each and every ordered pair. When you are going to taking inverse to each and every ordered pair at a time, first element becomes second element and second element becomes first element. Like that concept we will see in case of inverse relation here. How means now I'll show. And before that, we should write set builder form of inverse relation. In which way we are going to writing about that now we'll discuss here. See here. The set builder form of the set builder form of the set builder form of inverse relation. The set builder form of inverse relation is given by is given by or inverse is equal to b comma a such that the ordered base set of all ordered base must be in this form b comma a such that a comma b belongs to capital R. Like that, we are going to writing set builder form for the inverse relation capital R. But even just by taking that example, easily we can analyze about this. Because easily we can tell now, when the relation defined from A to B, just if we can take conversely nothing but here, inversely from B to A, then we are calling those relations are called inverse relations. Now, we are going to giving one example for the inverse relation. Because by showing or by seeing that examples for each and every relation, you are going to analyzing and you are going to understanding well also about all these relations. Example for inverse relation. Let's A is equal to set of the elements 1 comma 2. B is equal to and B is equal to set of the elements 3 comma 4 comma 5. Then A cross B is equal to A cross B is equal to here. So the elements 1 comma 2 cross. So the elements 3 comma 4 comma 5 here. That is relation A cross B is equal to we can take here universe relation R is equal to we can represent R is equal to here. See here start with 1 comma 3, 1 comma 4, 1 comma 5. Next one is with 2, 2 comma 3 and 2 comma 4 comma last one is 2 comma 5. Like that it is the universe relation. With 1, we will get the 3 elements that is 1, comma 3, 1, comma 4, 1, comma 5. With 2, we will get 3 elements 2, comma 3, 2, comma 4, 2, comma 5. And for this, take R inverse. R inverse means just interchange them. In place of first element, we should write second element. In place of second element, we should write first element. That is, take them reversely or conversely, then they are all becomes elements of inverse relation here. How means I will show now. Just we can interchange them 3 comma 1. Next one is the 4 comma 1 comma. Next one is the 5 comma 1. Next elements are take reversely 3 comma 2. Next one is the 4 comma 2. Next last one is the 5 comma 2. Like that we take them reversely. If we can take elements like this, they are all belonging to the inverse relation. Like that we are going to giving a example for inverse relation here. Under this, we are going to giving some important notes under domain, range, and codomain here. Means because whenever whatever we are going to giving some important notes and important points under the note of all these concepts, they are all very important. If you can put concentration on those notes, and they will be most useful to in competitive level examinations also. And that's what, after completion of those definitions, I am going to giving some important points under the notes of those concepts here. That ways, because we are going to, we need, they are always need to us in wherever we are solving some important problems also here. Now let us, we are going to giving some important points under the note of all these concepts here. Now here, number one, domain and range. Domain and range of null set is always null sets. Is always null sets. Domain and range of null relation is always a null relation only. In that null relation, we are not seeing any elements now. Null empty means here. Where empty is, if you want to write it here, no problem. Where empty is equal to here null relation or empty relation, we are calling this null relation. That's what we can write here. Domain and range of null relation is always null on null relation only. Null set only. Where null is, null relation is always null, empty. Empty means we are not getting any element. Whenever a null relation means we are not getting any elements, means even we are not going to getting domain and range also. And that's what is one of the important point under the notes. Next we are going to writing one more here. Second notes. Let us we are going to writing second notes. Second note. Let capital A and capital B. Let capital A and capital B be two non-empty sets. Be two non-empty sets such that if the universal relation, if the universal relation if the universal relation if the universal relation is defined from set A into set B, set A into set B, then domain is domain of relation, domain of R is set A, and range of set A and range of R is range of or capital R is set B. Like that we are going to giving a important point to here, because Whenever A is some one set and B is one set, take a Cartesian product between those two. Whole product is A cross B means here universal relation. In that universal relation, capital A is always becomes domain and capital B is always becomes range here. Like that here we are seeing different types of nodes here. Important points. Excellent. Yes, we are going to solving different types of problems on relations. How we are finding domain, how we are finding range, and how we are finding codomain. Like that, we will solve different types of problems. And we are going to collecting like all these problems. Exercise 2.2. It's not tough. And the previous class I have given definitions, concepts of domain, range, and codomain. Now, same formulas here also we are going to apply to find all these three from the given problems of exercise 2.2 here. That is, we are going to solving the problems from exercise 2.2 now. Exercise 2.1 here, 2.2 here, 2.2 here. Let A is equal to, let's, A is equal to 1, 2, 3, 4, up and so on, 13, 14, like that. They gave 14 elements here. Define relation capital R. Define a relation capital R. A relation capital R from set A to set A. From A to A. From A to A. From A to A is given by is given by or is equal to or is equal to x comma y says that 3x minus y is equal to 0. X comma y such that 3x minus y is equal to 0. And also they mentioned here where x comma y belongs to capital A. We must have mentioned here where x comma y belongs to capital A here. Where x comma y belongs to capital A here. Based on that, they're asking one question. What is the one question is? Write down this domain. Write down H domain comma codomain and range. They're asking these questions. With the help of that given definition, we are going to finding domain and codomain and range. How here? They give set of the elements also. They define one relation. It is defined one set. A is equal to elements of the sets are given by 1, 2, 3, 4, up to and so on 13, 14. Up to 14 elements they gave here. With the help of all these 14 elements and with the help of given definition, we are going to finding domain, codomain and range. Let us, we are going to solving the solution to this question now. Solution to this question. Let the given relation, let the given relation, let the given relation or is equal to x comma y such that 3x minus y is equal to 0, where x comma y belongs to capital A. Capital A is defined on the sets. Is defined on the sets. A is equal to 1 comma 2 comma 3 comma 4 comma up to and so on 13 comma 14 they gave here. See, by diagrammatical representation we are giving answers also very easily, because if you can move through the diagrammatic representation, then solution becomes very easy to us, and it is a little bit easiest way to analyze the solution of this problem also. How means I'll show now. It is one side, take one side here, A here, and here you can take A here. A is one relation capital R, and take some elements 1, 2, 3, 4, 5, 6, up to and so on, 10 and 14 here. Here also take some elements 1, 2, 3, 4, 5, 6, 7, up to and so on, 10, 11, 12, 13, 14, like that. Total elements, 4 elements they have taken here. Here the given formula 3x minus y is equal to 0 they gave here. Send 3x that side, it becomes minus y is equal to minus 3x. Minus minus gets cancelled. Then you will get y is equal to 3x. Based on this formula, we can find out the elements of the relation capital R. So means how means it is considered x. Here y is equal to 3x. If x is equal to 1, then y is equal to 3 into 1, 3. X is equal to, then y is equal to 3 to the 6. X is equal to 3, then y is equal to 3, 3 is a 9. 9 here will come. Next, x is equal to 4, then y is equal to 12. X is equal to 5, then y is equal to 15. We are not getting 15 here because just they gave only 14 elements. Up to 14 only will get here. That's what we are going to give in relation, writing relation capital R is equal to, we can write here elements like this. 1 is associated with element 3, that is 1 comma 3 here. And 2 is associated to 6, that is 2 comma 6 here. And 3 is associated to 9, 3 comma 9 here. And 4 is associated with 12, that is 4 comma 12 here. That's all. These only elements of the relation capital R. Based on these relations and based on those two sets, we are going to finding the domain, codomain and range here. First, domain. Domain is set of all elements of the first elements of the relation set of all first elements of the relation capital R is called domain. Like that I have given definition on last class. See here, what are the first elements? 1, 2, 3, 4. That is the 1 comma 2 comma 3 comma 4 only here. The range. Range means already I have told definition for range also. What is the definition for range? Set of all second elements of the relation capital R is called range. Now second elements, what are the second elements here? 3 comma 6 comma 9 comma 12. Next last one is codomain. codomain here. Even I have given definition for codomain also. Let capital A and capital B be two sets. Then the relation capital R is defined from set A to set B. Set A to set B. Then whole set B is called codomain of the relation. Like that, I have given definition for the codomain of relation also. Here, whole set B means what are the elements of set A? A also becomes second set. This becomes second set here. Here first set. Because here relation is defined on set A only. That's why A becomes first set and A becomes second set. That's why whole set A is called becomes codomain here. That's why A is equal to 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, up to and so on, 13, comma, 14. What is the second set? That is why it is belonging to which set? That whole set is called codomain. What are the elements are associated of the elements from the first set? Then we are calling them as domain. Here we are getting some elements. Now those are all images, but we'll see concept of images in functions. Those elements are called belonging to range. Like simply by taking definitions also easily we can tell about domain and range. Domain is the set of all first elements of the relation capital R is called a domain. In case of range, set of all second elements of the relation capital R is called a range. Whole set B, that is second set, what is the second side? That whole set B is called codomain. Like that, we are going to find a domain, range, and codomain. And one more method is that if you don't want diagrammatic representation means directly you can take substitution also. I'll tell you and I'll show you about that method also now. Second method, say second method. Let the relation capital R is equal to let the relation capital R is equal to x comma y such that 3x minus y is equal to 0, where x comma y belongs to capital A is defined on is defined on A is equal to 1 comma 2 comma 3 comma 4 comma up to and so on 13 comma 14 here. Second method, without using diagrammatic representation, how we are getting those elements, about that I am telling here. But here, with the help of diagrammatic representation, I showed how we are getting elements directly. Directly we got those elements here. Here I will show you here. Given formula 3x minus y is equal to 0 here. That is minus y is equal to minus 3x. Minus is cancelled. Y is equal to 3x here. It is the based on this formula we are going to finding the elements of the relation capital R here. How means I will show you. If x is equal to 1, then y is equal to 3 into 1, that is equal to 3. And for this we are getting The first element is 1 and second element is 3. 1 comma 3 here. If x equal to 2, f is equal to then y is equal to 3 into 2 is equal to 6. For this you get one ordered pair 2 comma 6. Next, if x is equal to 3, x is equal to 3, then y is equal to 3 into 3 is equal to 9. It is a second or third ordered by 3 comma 9 here. If x is equal to 4, then y is equal to 3 into 4 is equal to 12, and it is the fourth ordered pair, that is the 4 comma 12. And finally we are going to attain in relation capital R here. In relation capital R here, R is equal to here, R is equal to elements of 1 comma 3. Next one was 2 comma 6. Next one is 3 comma 9. Next one is 4 comma 12. Based on this relation, we are going to writing the domain, range and codomain. Range is the set of all first elements of the relation capital R. Domain is the set of all first elements of the capital R. Range is the set of all second elements of the relation capital R. Now we should write about these two here. Codomain is the whole set B, the second set. Only A becomes first set and A becomes second set because they define that relation only one set. That's why whole set becomes here codomain. See here. That is R is equal to here, R is equal to 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. At the same time, it is defined on relation on set is A is equal to 1 comma 2 comma 3 comma 4 comma up to and so on 14 here. For this, we can write here domain is set of all the first elements of the relation capital R here. What are the first elements here? 1 comma 2 comma 3 comma 4 here. Range is the set of all second elements of the relation capital R. What are the second elements here? 3 comma 6 comma 9 comma 12 here. Codomain is whole set. Whole set is called codomain. 1 2 3 4 up to so on 13 comma 14. Like that we are giving answers for domain, range and codomain in case of relation capital R is equal to 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12 here. 4 comma 12 here. Like that it's the second method. First method is I have given direct method. Diagrammatic representation, that is direct method. It is the indirect method, means that individually, that is separately we are going to finding elements for the relation capital R here. Like that we will solve different types questions on next class. Up to this I solved. Today I told about inverse relation, and at the same time I have given some important points under the note of domain, range, and codomain. And even I have one important point in the previous class also. Range is always subset or equal to codomain. Range is always, see here, range is 3, 6, 9, 12. All these elements are present in set here. Whole set is 3, 6, 9, 12. Here they are present here. That's why by taking or by seeing this domain and range, the domain, range and codomain, range is always subset or equal to codomain. That is also one important point. In the previous class I have told that also. Next class onwards we will solve some different types of problems on relations. Though we are going to collecting those problems from exercise 2.2 only. Just have finished only one or two questions from exercise 2.2. Next class onwards we will solve some different and important types of questions from exercise 2.2. Thank you very much.